I'm Steve Darcey with GoEngineer, and today we're going to do a comparison using SOLIDWORKS, and we're going to compare the APEXX S3 by BOXX versus the HP Z6 G4. Now both of these are the recommended SOLIDWORKS workstations, and let's just see how they compare, see who's fastest. So we're going to take a quick look at reboot times, because of course engineers like to reboot, make sure that their systems are clean. So here we go, ready for a restart. Looks pretty good, we got a fair click on the mice. So looks like the HP actually shut down a little bit quicker. We'll see which one comes up faster. So it looks like a little bit of additional code, HP Sure Start. And we're already logged in on the box and ready to get to work. Let's go ahead and fire up SOLIDWORKS. And we'll go ahead and start prepping for the next test. Looks like the HP is up and going. So a good comparison to see which workstation is actually faster is opening up a large assembly. So I've got a fairly decent assembly. I am loading this guy fully resolved. And so let's start this guy up. Ready, 3, 2, 1. Alright, looks like we got a pretty good click on that. And while this is starting to open, I'm also going to pull up the task manager. And there's a lot going on when we open up an assembly. We have to open up each individual component, open up another component, make sure that those are rebuilt. Hopefully I suppressed all of the rebuilds. I am doing a full rebuild on each part. And then it has to rebuild the mates that are in between each of the parts. And fully resolved, it's going to load everything. So this is a 2,336 piece assembly. Not large. We have some companies have 65,000 piece components. But this should give you a good weighted average. Notice again, kind of the CPUs on these things. We're not overclocking them fully out, because most of this stuff is going to be single core. Opening up a part, rebuilding, refreshing, updating the mates, and then doing that over and over again. So we can also notice that looks like we got a 3.7 gigahertz processor, but our actual speed is 4.77 gigahertz. So considerably faster. This we're at about a 3.6. This is a Xeon Gold 5122. It's about a $1,200 processor, and we're kind of maxing out about 3 gigahertz. I think when these guys get a little bit warmer, then they kind of slow down the clock speed on those. Since we're liquid cooled, we can pretty much run fully optimized. So it looks like we're getting pretty close. It's updating the assembly now. All it's got to do is generate the graphics and we're done. We're right about 2 minutes in. It says 156, but it's still kind of going. And it looks like the box is up. We can rotate around, start getting to work. So a little over 2 minutes, probably about 2 minutes, 4 seconds, something like that. Take a look at my little pumps down there, make sure that they all came in right. And it looks like the HP now, we're about probably 2 minutes, 30 something seconds. It's just finishing up generating the graphics. There we go, 244. And maybe even another 5 seconds for that as well. All right, and we're fully open. So there we go, there's the open test. So I have my large assembly up. and we're going to see how long it takes to create a drawing. So let me go ahead and start up the initial drawing. And I went ahead and moved the task manager over to the side so you can see the CPUs and kind of see what's going on while it creates, what goes on when we create a drawing. So I'm just using the ANSI B-size landscape. I'm going to cancel out of this, and we're going to drag them in from our view palette. So give me a second to get this set up. You should see our views populate here. So I'm going to drag in two different views. One is kind of the top plant view layout, and then I'll pull in an elevation. So we'll start off with this guy. And there actually is some CPU stuff kind of going on here, because it is having to do kind of a calculation on all the views when it's populating this. So here we go, we're up. So I'm going to start off with the plant view. So I'm going to try and drag this over as quick as I can and drop it, but try and be... So here we go, I'm going to click, drag. There's the preview, I'm going to drop it. There we go, dropped it. And then I'm also going to go to a hidden lines. So that was pretty quick. Let's go and drop one more in here. And this we're going to do the plant elevation. Find it, there he is. So again, we're going to drag and drop. So you can kind of see him hang. There is the box is up, now the HP is up. So, you know, a little bit of a difference, couple seconds there. So not too crazy, but that is kind of a lot of geometry that's going on there. And this does have a little bit of finding out the silhouette edges and stuff like that. Some of that stuff we can do with multiprocessors. So pretty comparison. We got a little bit better performance on the box, but you saw on the assembly open time, very large performance. I probably could have already created this drawing and been up and going on some other work. But pretty good comparison there. All right, so one thing we want to look at, especially if we have multiple cores, is simulation. So this is SOLIDWORKS simulation. When we're doing a pressure vessel analysis, we actually have to do a pressure study, then maybe a temperature study, maybe some inlet nodes or some other type of loading. And then what we do is on the vessel itself, we're actually going to combine some of these results. So to get a good analysis, we're actually going to run all studies. They're all set up the exact same. So I got a good click on that. And here we go. So we can kind of see which ones are running right now. And we can take a look at the processors and see how well they're running. Now initially when it's creating the mesh, it's all going to be single core, so you won't see these things start to max out. Once the mesh is created, then it's going to go in, complete the study, and we should see some of the cores kind of pop up a little bit more. So it looks like the box is done. I may have messed up my mesh settings on that one, but you can kind of see it finished all the other studies, totally complete. You can see the CPUs. You may kind of say, well, you know, this guy has 6 cores and this guy only has 4 cores, but they're both about a $5,000 machine. So, and this is what HP recommended for the use on SOLIDWORKS. So the studies are set up the same. We should see probably a fail on the Vessel 1 study as well on this one. All right, and it looks like the HP is finally done. Again, this is kind of my error on the pressure and temperature. I should have copied the mesh, and then that way the pressure vessel study would have completed. But for the most part, you can kind of see that step by step, and that's half of engineering, is figuring out what didn't work and fixing it. But you can tell that the S3, of course, surpassed pretty much. We finished an entire study before the HP actually got to the end round. So another good speed test is, of course, CFD, or SOLIDWORKS Flow. It's a computational fluid dynamics. And this is where we're really going to max out the CPUs. We'll see which one can win. So a little bit on this setup. It's pretty much like a little muffler configuration. I have an inlet velocity. So I have you know, gas or fumes coming in through here, 12 meters per second. It's coming in at ambient temperatures and pressures, so nothing kind of weird on that. But I do have a couple goals in here where I'm testing what the pressure drop is around some of those. So I'm going to keep some of that information. And then I have these little cartridges. One of them is isotropic, so we'll actually see kind of the flow lines separate in different orientations. And then I have a uni-iso in which they're going to be unidirectional. So once the flow comes in, it can only go in one direction. In this case, about the z-axis. So I have both of these set up. We're going to run them both at the same time. So let's see if we can get a good click on that. So we're going to do a batch run. So Flow's been able to do this for quite some time. And we'll hit the run button. 3, 2, 1, click. All right. We'll go and minimize this screen a little bit. Put that up in this corner. Kind of get the box configured as well. Looks like actually the box is already done with the first one. So it's working on the second one. HP is done with the first one. And we're done on the S3. The box is complete. So now we can take a look at some of the results if we want. And we can take a look at some of the flow lines. All right, and the HP is done. So pretty quick. Those came out pretty fast. Let's load in the results. And same kind of thing, play the flow lines on there. So not too bad. Pretty fair comparison on this flow test. All right, so let's see the actual results. I'm going to pull up the summary. So the physical time, CPU time there was at 9 seconds for that one. This is resultant number 2. And we have CPU time is 15 seconds here. So a pretty good variation, and you know, it looked to me like they were pretty close in time, but there's actually pretty big discrepancy in time there. So we've taken a look at the speed of the processors and that kind of stuff. Now we're going to take a look at a little bit more of the GPU. These both have NVIDIA P4000 graphics cards. You can kind of see I've got a SOLIDWORKS Visualize open. This is a full realistic rendering engine. We can drag and drop colors. And it's real time. We can change the background. So that looks pretty good. And you can kind of see the per pixel rendering on that. And we get the live real ray trace. Let's go ahead and do one more thing. See how fast this thing actually works. We're going to go ahead and render this guy out. Our output tool, we're going to go ahead and just do a JPEG, 100% resolution. Some of the settings that I have here. And so this is straight out of the box. This is one of the sample parts. So if you guys want to try this at home, you can see how well this works versus your workstation that you're working on. So I am doing an accurate rendering here, 100 passes there. and I am doing it to the GPU. So we'll go ahead and start the render. 3, 2, 1, click. And here you probably won't see as much CPU side right here, but you will see more on the GPU side. So I'm going to turn my graph over here to GPU. You can kind of see the memory, of course, is going to crank up. The 3D is cranking up a little bit. And we're starting to get, we're on past 46. Here on the S3, we're on 77 now. And we're done. We're on past 100. We've completed the render. So a couple seconds later, the HP is up and going. So pretty good little speed test. And again, these are both exact same systems, exact same software drivers, recommended by SOLIDWORKS. So I want to thank you guys for joining us on this comparison between the APEXX S3. It's an i7 overclocked liquid-cooled workstation, along with the HP Z6 G4. It's a Xeon quad-core workstation. And these are the top level ones that, of course, HP and BOXX recommend for SOLIDWORKS. So we did some nice comparisons between the open assembly time, creating drawings, simulation, some of the flow analysis, and then finishing up with some of the rendering. So of course, if it were me, I'd pick the BOXX. Don't forget to watch some of our other videos, along with the old BOXX versus new BOXX, and also the BOXX versus Dell. If you have a Dell workstation, that's a really good one.